Okay, so we have a question here. It says the third Taylor polynomial for the function is given as f of x is equal to the square root of 1 minus 3x. And this Taylor polynomial is evaluated about x is equal to -1. Okay, so the first part says find the value of x such that that can be used in P3 of x to approximate the square root of 3. Okay, so we need to find the value of x that I'm going to use in this polynomial of degree 3 to approximate the square root of 3. Okay, so let's start. So part 1. So given the function equal to the square root of 1 minus 3x. And this, we're evaluating this polynomial about x going to be 1. So the expansion of this up to the third degree Taylor polynomial, okay, is given as P3 of x equal to 2 minus 3 over 4 x plus 1 minus 9 over 64 x plus 1 squared minus 27 over 504 x plus 1 cubed. Okay, so this one you can get this expansion from the Taylor polynomial expansion. You know that if Pn of x is equal to f of x naught, okay, plus f prime of x naught, and then x minus x naught plus f dot prime for the second derivative about x naught, x minus x naught squared divided by 2 factorial plus so on and so forth. Okay, so this will be f n minus 1 x naught, and then x minus x naught n minus 1 divided by n minus 1 factorial. Okay, where n moves from 1 to infinity. Okay, so that's the expansion for Taylor polynomial series. Okay, so now the expansion here in this problem has already been done for us. We don't have to do all this kind of expansion here. So everything is already done for us. All we need to do is just make use of the expansion given. Okay, so let me just get rid of this. All right, so what's the first thing here? The first thing, we need to find the value of x that I'm going to use to approximate the square root of 3. So what do we do with that? Okay, so you notice that our function given here is a square root function, right? It's a radical function. So this means that what we have here inside of 3, inside of a square root, must be equal to 3 because we are trying to approximate the square root of 3. Okay, so can you just imagine that you put a 3 in this square root, and then you try to approximate. So instead of us having a 3 direct, we are given a 3 in terms of a function, and that function has been expanded using a Taylor polynomial. So all we need to do to find the value of x that we can use to approximate the square root of 3, we can just equate the two. So we're going to equate 1 minus 3x to 3, and then so for x. Okay, so we're going to have 1 minus 3x equal to 3. And then if you solve for x here, the value of x is giving us -2 over 3. Okay, so x equal to -2 over 3. And then next, we need to use the same value we found. Okay, that's part 2. The same value found to approximate root 3. Okay, so we're trying to approximate root 3. So we are given the polynomial. So we have to evaluate this about it. That value of x -2 over 3. Okay, so we're going to approximate the square root of 3. So this is equal to 2 minus 3 over 4 -2 over 3 plus 1 minus 9 over 64, negative 2 over 3, plus 1 squared, minus 27 over 512, negative 2 over 3, plus 1 cubed. Okay, so meaning the square root of 3, therefore, can approximately be equal to, okay, so this approximation is symbol here. Okay, can be approximately equal to, if you have to put all these values in the calculator, get 2 minus 3 over 4, and negative 2 third plus 1, and then minus 9 over 64, negative 2 third plus 1 squared, and then minus 27 over 512, and negative 2 third plus 1 to the power 3. So this gives me about 173, okay, 1.73, 2421875. Okay, so you can conclude that the approximation of square root of 3 using this the given Taylor polynomial is equal to that. Okay, and if you look at the actual value, okay, you can also check for the actual value. So the actual value is simply equal to, so if you get the square root of the 3, and okay, so if you punch this in, I get square root of 3, that is 1.73, 2050808. Okay, so you notice that they're not very much far from each other. Okay, so thank you so much. See you in the next video.